All right, everybody. We're going to start the next session. We've got Paul Kehrer here. He's traveled all the way out from Austin, Texas. This is his first time in South Africa and actually the first time in the African continent. So I'd like to welcome here today. Thanks, Paul. Over to you.
All right. So hopefully everyone is adequately refreshed and ready for 30 plus minutes of excitement. But if so, you have come to the wrong talk. We're here to talk about reliably distributing compiled modules. So this is an updated version of the talk I gave at PyCon US with around 6 months of additional lessons learned. So this may contain some recycled material. So who am I? Well, I'm Paul Kehrer. I write software, I kiteboard, and I bake things, and not necessarily in that order of interest. I'm an inveterate Simpsons quoter, and I am Reaperholic on essentially every service you can find on the internet. Turns out that name's not super common, so it's easy for me to get. If there's any service you're aware of where I don't own it, let me know so I can squat the name immediately. What I work on. As an employee of Rackspace, as I see, I can represent my company in one regard today. I do occasionally work on things for my employer, but I actually spend the majority of my time on the Python Cryptographic Authority, which is upstream open source Python work. Specifically, I spend the majority of my time on cryptography, but I also contribute to PyOpenSSL, Pynacle, and bcrypt. And then on the side, I do a little site called Frinkiac and Morbitron, which allow you to do Simpsons and Futurama searches with memes and GIFs, but that's a separate talk. So why this talk? Python is simple, and all you need is pip, right? Ultimately, what we want here is that upon typing pip install your package, we get the software we want without errors and preferably reasonably quickly. In other words, we want compiled or binary modules to act like regular Python and just work. For the purposes of this talk, and of course my own ego, we'll be using cryptography as a demo of user experience with a compiled module. But of course, what is a compiled module? Well, facetiously, it's any module that uses binary code, right? But perhaps more usefully, it's a module that calls code not written in Python. In some cases, this might actually be code that's simply deal open, so no compilation is required. But in the majority of cases, it will be some C code that needs to be compiled using GCC or Clang, which in turn calls system libraries or other bundled libraries that are also typically compiled C code. Of course, it doesn't have to be C, but the CABI, or Application Binary Interface, is generally the lingua franca for FFI, which is foreign function interfaces. Common ways to write the type of compiled modules we care about here include the CPython CAPI and CFFI. So let's install some software on a Linux VM. We're going to use Ubuntu 14.04 with the latest pip in a virtual environment because we're up-to-date developers, but we forgot that 16.04 came out 6 months ago. We're also experienced people, and we know that if we want a compiled module, we probably need a compiler. So we type the magic incantation needed for that on our platform. For you pedants out there, I am aware that these are not equivalent commands, but they are pretty commonly typed by the users of these respective distributions, and they work fine for our purposes. All right, we're ready. We've got all the things we need, right? So let's pip install cryptography. Oh, okay, well that clearly did not work. But actually, as you can see from the snip markers there, that's been simplified to actually show the relevant error. The real error looks more like this. Well, not quite done yet. Oh, we're almost there. Ah, there we go, the final error. So what actually went wrong? Well, there's no python.h. Python.h is the primary include header for Python itself. But of course, we're all experienced people who know everything about this sort of thing, so we know how to solve this. We just need to go ahead and apt-get install dev python, which are the Python development headers. And we, of course, know that they're called python-dev and not python-devel if you're on Red Hat-derived distributions, or a Google search or 3 or 4 away when you're on TinyCore Linux or Alpine or on some other unusual distribution. So does it work now? Well, still not quite. But fortunately, we are all operations and C toolchain experts, so when we see include ffi.h, no such file or directory, then we know that means it's missing the libffi development headers. So no problem, we'll go ahead and install those. So we install our libffi development headers. Oh, come on. All right, we've come this far, and I refuse to let a computer beat me. In fact, that is going to be inscribed on my headstone. So let's install the OpenSSL development requirements. So we go ahead and install them. Oh, sorry, that's the wrong operating system. So there we go. Or was it, or maybe even, well, regardless, I'm sure we'll figure it out. So we try one final time, and this time, success. We have finally managed to install this software. So we guessed that we'd need a compiler at the beginning, but what is actually required? Well, the real prerequisites are, of course, the compiler, which we've already discussed. Typically, that's going to be GCC, Clang, but it's also Microsoft Visual Studio on Windows. Sometimes it's things like MinGW. It can be more than just the standard set of compilers. If you're compiling against a library, or then you're going to need a library. And of course, if you're trying to compile and not just DL open something using the ABI, you will need the headers as well so that you know what the function signatures that are available. And of course, that also tells you the layout of the memory for things like structs. So we have several platforms we care about. One of them is compiling on OS X, or as Apple would now like us to once again call it, Mac OS, because everything old is new. If you're on a system older than 10.9, you're in trouble. For one, please upgrade. 10.9 came out 4 years ago now. It's about time to get up onto within one of the releases that's actually supported, which actually Apple only supports 10.12, 10.12, 10.11, and 10.10. So you should definitely be upgraded. If you're on an older version, you're going to have to find the Xcode tools somewhere. At this point, they may not even be on Apple's developer site, so you may be going to like download.com or something where you can get some malware along with your dev tools. But otherwise, you can use Xcode select -- install, which actually will install the command line compiler tools. It's about 60 megabytes. It's really quite simple. So that's actually one of the nicest things on there. If your software depends on libraries outside the OS X default, and that's, of course, very common, then you're going to have to install Homebrew or Mac ports as well, so that they have a package manager to grab the additional dependencies. You can, of course, also bundle your code with your Python module, but in many cases, that's impractical. For example, in cryptography's case, you'd need to brew install OpenSSL in addition to the Xcode select. Compiling OpenSSL as a component of installing a Python package would be, let's call that unpleasant and leave it at that. On Windows, Windows is a little bit tricky. So you're going to need many versions of Visual Studio. So for Python 2.7, Microsoft has actually made this simple recently, which is that they've created the Microsoft Visual C++ compiler for Python 2.7 package. What that is the Visual Studio 2008 compilers pulled out of Visual Studio and made a standalone package. The reason they did this is that Visual Studio 2008 is no longer supported, and the only way to download it from Microsoft is if you have an MSDN subscription so that you can go back and download old software. So that was a serious problem, so it's very nice of Microsoft to have resolved that for us. On Python 3.3 and 3.4, you're going to need to use Visual Studio 2010, and Python 3.5 uses Visual Studio 2015. Python 3.6, which is coming out soon, will also use Visual Studio 2015, and the compiler situation on the Windows side is actually improved going forward. Microsoft created a new thing called the Universal CRT, and it doesn't matter a whole lot what the common runtime really is, but Python 3.5 and above now link against that, and that will eventually free us from the tyranny of MSVC version matching. Unfortunately, everyone in this room undoubtedly cares about more than just Python 3.5 and above, so for now we need to care about all of this. There are also 32-bit and 64-bit versions of Python on Windows, and they require compilers on the corresponding architecture. As mentioned previously, Visual Studio 2008 stuff, you got both. On Visual Studio 2015, you also get both. But in Visual Studio 2010, which Microsoft still sells, they do not give you the 64-bit compilers for free. Fortunately, they are available in the Windows SDK, and I believe that's version 7.1, but you should probably confirm that for me. And that way you can get all the compilers you need. There's also, of course, no package manager for getting third-party libraries. There are things like Chocolate, but in general, you can assume your users won't have those installed. So you'll need to your users will need to obtain those libraries on their own. So we've covered what it takes to compile on Linux already in our previous experiment with installing cryptography. But to recap, On Linux, each distribution has its own view of what packages provide the basic compiler tools. So that's the apt-gets, the yums, the DNFs, the variety of things that are like that, and of course the different names for each package. And then of course those same package names may not be what you need, because you also need the development headers for those sorts of things. And the convention for what constitutes the name of a development header is different based on which distribution as well. This all adds up to being a relatively complex process for explaining to users what it is they need to have installed to be able to use your package. There are, of course, even more problems than that. C toolchain lookup paths. When compiling modules, the C toolchain looks in standard locations for includes and libraries. If alternate software is installed separately to avoid conflict with system packages, then users might have to pass environment variables like C flags or LD flags to make the compiler and linker look at the correct place. This is actually a specific requirement in the case of cryptography on OS X, where userlib contains an existing libSSL and libcrypto, specifically one from many years ago. But we want to link against the homebrew version, because that version is actually up to date and not riddled with security holes. But that resides in a completely separate directory. So we have to pass a bunch of additional flags during the compilation process. However, when doing this on Linux, you may also need to explicitly specify linker flags, like setting the R path and other things to make it use the right shared library. Or else you're going to have to do things like LD preload or LD library path interposition. You may even end up modifying SO names and things of that nature because of the way the dynamic linker works on Linux. You might have unsupported library versions. The version of a library installed by the OS package manager may be too old or too new, and thus unsupported by the Python module. The interfaces for a given library will evolve over time, and by necessity, the Python bindings need to change with it. If they don't match, then the strange compilation errors may occur that will result in all sorts of interesting GitHub issues filed. And then to what we talked about a little bit earlier, Windows CRT and compiler restrictions. It's a relatively simple requirement, but it's very unpleasant. All the artifacts on Windows must have been compiled by the same compiler version. So the module that you compile must be compiled against the same compiler as Python was originally compiled with, and any libraries that you may choose to link against must also be compiled in the same fashion. So that means, because, going back to that original issue, the reason that we need Visual Studio 2008 with Python 2.7 is because when Python 2.7 was released, Visual Studio 2008 is what it was compiled with. We are stuck with that for all time. And finally, people do terrible things to their computers. Any number of other crimes against the same C build environment may have been committed in the past on a user's machine. Installers for projects will litter a user's file system with binary detritus and configs that may wreak havoc with your module's expectations. It is not uncommon, on the Mac at least, for people who've installed MySQL to have DYLD library path interposition set by default. And that can sometimes cause some very serious problems. So obviously this is not a reasonable situation. And it is an unfortunately common experience for developers and end users installing software with compiled Python modules. If you don't believe me, search Stack Overflow for 5 seconds. Binary modules cause a bifurcation of the user experience. On the one hand, you have the good packages. Those are the pure Python packages where installation just works. You pip install it, you put it in a virtual environment, you do whatever you want, it's all fine. And on the other hand, you have the transcendentally awful, which is the experience we had when we were trying to pip install cryptography without an understanding of what our actual requirements were. Shockingly, non-Linux platforms, especially Windows, can actually be far more challenging than what that initial example looks like. In general, most Windows users, when confronted with the reality of needing to compile a binary package, will give up. They will not use your project. So wouldn't it be nice if we could distribute pre-compiled software like the operating system package managers do? Then users wouldn't have to know all this just to use some software, and the maintainers of said software would not be inundated with issues like what's above there. Or the Bing version, which apparently has many, many more results. So why can't pip install cryptography work as if there's no CMagic inside? Well, obviously with wheels, mostly it can. Of course, like any purported panacea, there are a few significant caveats that we'll talk about a little bit later, but for now, we're going to talk all about the roses and sunshine. So wheels are specified in at least 3 PEPs and probably several more. They provide a way to distribute Python artifacts, and they are superior in a variety of ways to eggs and sdist, although they are not a complete replacement for sdist. They allow you to install packages with binary dependencies sans root. What I mean by that is if you have bundled your binary dependency into a wheel, then you can install that in a virtual environment. You don't need to have sudo, you don't need to have root to be able to apt install the dependent packages. Pip can both produce and install them, and when I say that I mean with the assistance of the wheel package, but the pip wheel command. And then there are tags that are used to denote how a wheel works. I'm not going to say a whole lot else about this since many, many excellent talks have been given on the wheel format, so let's instead talk about how a project can build these artifacts. So we have now reached the part of the talk where I theoretically impart useful information instead of just bemoan the state of things. You need to look deep within yourself and ask yourself some questions for your project. What platforms do you care about? In general, for building binary wheels, you should at minimum care about Mac and Windows. They are the most popular non-Linux platforms, and PyPI supports uploading of wheels for both. Many Linux 1, which is a thing we'll talk about a little bit later, now means you can also potentially supply binary wheels for Linux users. But there are some caveats around that, although largely in the last 6 months, many of those have vanished. What versions of Python do you care about? Do you care about Python 2.6 or Python 3 less than 3.3? I urge you not to care about Python 3 less than 3.3 for sure, and ideally not Python 2.6, but I understand that some of you may still have to. What about PyPI? The answer to this, combined with the platform question, gives you almost the number of wheels you'll need to build. More Pythons means more wheels and significantly more infrastructure complexity if you're supporting Windows due to the multiple MSVC requirement. For reference, cryptography currently uploads 21 wheels to PyPI, but our requirements are somewhat extreme. And I should note that that does not include any many Linux 1 wheels, which would add another, let's see, that would add another 8? Oh no, I'm sorry, 16. Can you rely on the library you need to be present on all platforms? If not, and the answer is commonly no, you can't. You're going to need to make some decisions about how you want to ship it. If you want an identical experience across all platforms, you're going to need to bundle your library with all the additional maintenance burden that implies. You may also have unusual dependencies like optionally binding to system libraries for only specific OS releases that may bloat the number of wheels that you require. So, to go through the 3 platforms, what's required on a Mac? You need a Mac. That's perhaps unsurprising. Apple has made certain decisions about whether or not you get to run a VM on anything other than Mac hardware, and they've decided no. So a Mac with any recent release will do, but really you should be on the last 2 releases. And assuming you don't have any OS 10 version specific dependencies, you can build wheels that work for pretty much any user on 10.6 and above. You're probably going to want to automate this, and we'll talk a little bit more about that later. So it's not necessarily a great idea for this to actually be your laptop. You may instead want to consider something like a hosted machine, like on something like a Mac Stadium or a Mac Mini Colo. You actually can run VMware ESXi on Macs and then run Mac VMs on that, so you can kind of build an infrastructure that makes sense in that regard. Alternately, and something that I've done on some of my own projects is we made our own laptops Jenkins builders for certain times. So that way we can kick off stuff that then goes to the Jenkins server and then triggers back to the laptop, which is a little convoluted, but at least gives you the automation that can ensure less mistakes. Of course, it wouldn't be binary artifacts without challenges, and we're going to go through 3 of them here. So first is OS X SDK versions. We can solve this problem actually quite simply, which is use python.org Python. Python.org releases are linked against the 10.6 SDK. This is a little bit less relevant than it used to be, but you can't install an OS X wheel with an SDK tag newer than the OS you're running. So what that means is if, like, for example, if you are a user who builds, or sorry, if you're a developer who builds their wheel on the latest Mac OS, which is 10.12, and then a 10.11 user tried to install that wheel, pip would ignore it because the SDK version is a mismatch. Conversely, if you build a 10.6 wheel, then anyone 10.6 and above can use that wheel. So that works well unless you need to link against OS X specific features that were added past 10.6, and then you need to start doing different things. In cryptography's case, we do care about that, which means we actually ship a pair of Mac wheels. One we build against 10.10 and one we build against the 10.6 SDK because we need to link against system services that weren't available in 10.6. Universal support. So universal is Apple's shorthand for binaries or libraries containing multiple architectures. Technically, a universal library can contain PowerPC, PowerPC 64, i386, and x86-64 code. Given that the x86 transition happened a decade in the past, though, we're going to go ahead and sweep that PowerPC stuff under the rug. To create a universal wheel, you'll need both a universal Python and universal libraries. Universal wheels will work with universal Pythons as well as x86-64 only Pythons or i386 only Pythons. Fortunately, Python.org Python releases are built universally, so they handle both the SDK and the universal question quite neatly. Of course, the libraries you link against must also be universal. Many homebrew libraries already ship as universal libraries, but sometimes you do have to do it yourself. In that case, there are a pile of flags to pass, and that's probably getting a bit out of the scope of this talk. If you're interested in how that sort of thing might work, then you can check cryptography's release docs, and it shows information about how we rebuild OpenSSL. And finally, UCS2 and UCS4, which is known as narrow or wide Unicode. So this is an issue that has only recently started cropping up for users on OS X. If you recognize the above here, you would have already stubbed your toe on it. But effectively, what it does is Python has two ways to compile Unicode support. And on the Mac, System Python is UCS2. Python.org Python is UCS2. Homebrew Python made an explicit decision back in 2014 to stay UCS2, but PyEnv, which many of you may use for having multiple Pythons simultaneously on a Mac, made a switch recently. This isn't surprising because PyEnv is used on more than just OS X, and on Linux, UCS4 has been the standard thing for quite some time. But it does add an additional configuration we need to care about because UCS2 and UCS4 means a different ABI, which means we need a different wheel. So, to handle all the things we actually need to do, we need Python.org Pythons. We need one PyEnv Python 2.7 that's built in UCS4 mode. And we need the patience to understand this ridiculous explosion of permutations. On Windows, we have another set of issues. You should first make life simple by building a separate VM for 32-bit versus 64-bit Python. You can try installing them all on one system, but tools like Tox have expectations of where they're going to find Python. They look for them in SQL and Python 3.5 or Python 2.7. And it will make your life much, much easier just to let them have their way. If you attempt to fight those tools, you will be fighting them in your automation forever. Of course, you're going to need all the different compilers we previously talked about, along with the Visual Studio 2010 Express plus the Windows SDK if you want the 64-bit compilers and all that. And you're, of course, on your own for libraries. That's the unfortunate reality of the Windows land. You might have batch files that help you build from some of them. Others might have Visual Studio project files. It's kind of the wild, wild west. It's surprisingly inconsistent there. So, Many Linux 1. Many Linux 1 is a PEP that has landed relatively recently and has been incorporated into PIP 8.1 and above that allows you to provide binary wheels on Linux that work across a wide variety of distributions. The way it's accomplished is a little hairier than you might like. Specifically, the Docker container that you see there is actually Red Hat Enterprise Linux 5. And the reason it's Red Hat Enterprise Linux 5 is because that supports a glibc so old that we know that if we link against it, it will work on newer things, and it will work everywhere. So glibc has very good ABI compatibility, so there's an assumption that we can move forward on that front. And then there's a certain subset of libraries that are allowed to be part of the Many Linux 1 profile. So the team behind Many Linux 1 who built this Docker container have done a lot of hard work making this build environment possible. So you can run the command you see above, and then you can run pip wheel against the variety of Pythons that are inside there. They even have an audit wheel package that checks to see if the resulting wheels it builds comply with the Many Linux 1 restrictions for linked libraries, and if not, if not, it copies the necessary libraries into the wheel automatically for you. You will, of course, have to do some of your own work to have it build the wheels, but it's relatively straightforward, and I'll have some links in a little bit about places where I've done that. So, to wrap up our requirements, you want something to automate all of this, right? There's many pieces. There are lots of places where you can make mistakes. This process is complex, and you will absolutely make mistakes without that automation. Rather than doing it by hand, you should have something kicked off during your release process that automatically builds them. In cryptography, we use a Jenkins job that is triggered by an invoke command during our release. The job builds and archives the wheels, and then it downloads them automatically and then uploads them to PyPI via Twine. I cannot stress this enough, and I say this from experience. You need to automate wheel generation or you will make mistakes. And you will make mistakes on just some of the wheels, so the bug reports that come in will make no sense to you. All right, I said that this was not a panacea, and here are some caveats. So users need the right version of pip to do much of this. And it really needs to be 8.1 plus, which is pretty much the latest version still. Now that has been out for well over 6 months now, but they need to be up to date. The wheel tags were only recently finalized for Mini Linux 1 and the wide narrow Unicode issues. So if their users aren't up to date, then they won't pull the wheels. It'll automatically just get the SDIS still. Based on the PyPI logs that you can anyone can look at, they're on Google BigQuery. OS 10 pip tends to be the most up to date, which is perhaps unsurprising, but Linux users are actually catching up quickly in the last 6 months or so. So there's a reasonably large amount of pip 8.1 out in the wild now. If the library you're using isn't guaranteed available, you're going to have to bundle it. This bundling can be accomplished either by static linking or copying the dynamic library. But now you, the wheel builder, are on the hook for updating your package every single time your upstream dependency changes. And your users are unfortunately on the hook for knowing to update as well. For OpenSSL, this is not a good thing to have to do. As users of a Mini Linux 1 wheel that links against libSSL might not realize that when they upgraded their distributions packages, it didn't update the Python code. It may be possible to somewhat avoid this issue in the future if more Linux binary wheel types appear, like an Ubuntu 16.04 or an Ubuntu 14.04 or a Fedora 24 specific tag, unlike the Mini Linux 1 tag. But it's still going to be a problem on Mac and Windows where we have no such facility. Another caution, when you're bundling a library that you built, you need to be extremely careful to compile it against a generic CPU target. Otherwise, you're going to get illegal instruction errors from users who attempt to install it on older processors that don't support the instructions you compiled assuming they had. Unusual architectures aren't supported by wheels on PyPI. So your MIPS router, your Open Power System, your Raspberry Pi will still have to compile it themselves. So even with all the wheels you're generating to try and make things so that people don't need a compiler, you're still going to have a significant fraction of users that need to run through the full build process. Of course, you should keep your full build process as easy as possible because you're already using it every single time you build wheels. So you want that whole thing to work quite well. This one's more of a hypothetical, but in large systems with many dependencies, an ecosystem where this sort of static linking behavior is common can result in increased memory footprint and download size. It's unclear if this is a significant issue outside of truly gigantic edifices like SciPy, but it's one to be aware of. The reason this can happen is that with a shared object, you only load it once into the process. But if you've bundled your own or statically linked it into your own module, then every single module that loads it will load it RTLD local itself, so it will pull in its own set of the same symbols over and over. All right, bonus content. Let's talk about Mini Linux 1 in the wild. Since originally giving this talk, I've had the opportunity to work far more extensively with Mini Linux 1. We wanted to try some trial deployments, see what would happen, because while its promise is very high, it was kind of scary thinking about the way it actually gets built. So what would be a good test case for Mini Linux 1? I have access to quite a few projects, but I wanted one that didn't have too many downloads, less than 100,000 a month, and we wanted to be cautious about the whole thing. So as a first pass, we chose to do bcrypt. Bcrypt is a small module without too many downloads. It's around 100 to 120,000. And it, of course, has the misfortune of being a project I control, and therefore I can do this. So I wrote a few scripts that allowed me with the Mini Linux 1 Docker image, to build the wheels we needed, and we uploaded them. And I'm not sure how readable that is, but These are all the download counts as provided by that BigQuery instance from 9.1 to 10.1, so last month. As you can see, a significant proportion of downloads are many Linux One wheels. Users with older pip or pin to versions where we don't offer a wheel, like 2.0 is a version where I didn't upload a wheel, I only uploaded wheels for the latest. They constitute the majority of our SDIS downloads. But the biggest news of all from this was, despite the fact that numbers 4, 5, 6, 10, 11, and 12 all are wheels, we got no bug reports from this change. It was a flawless changeover. So what if we discarded all caution? Let's do CFFI. I happen to have access to upload wheels there, and I filed an issue on the repo and convinced Armin to go ahead and let me try. And I made a repo that contains the scripts that work with the many Linux One Docker images. Essentially what they have to do is build the latest libFFI for x86 and x86-64, and then create the CFFI wheels pointing at that new libFFI. This is a bit more complex than our initial bcrypt wheel because it's now linking against an external library that then gets merged into the wheel during the creation of during the execution of audit wheel in the many Linux One Docker build process. But it's reasonably simple, and you can see all the scripts available right there. So again, the download counts from September 1st to October 1st. CFFI is a vaguely popular library. It gets about 4.8 million downloads a month, of which over 800,000 were many Linux One last month, again with 0 bug reports. And with the addition of a CFFI wheel, pip install bcrypt no longer requires a compiler at all on Linux. So edge to edge, you're able to go. So in the vast majority of cases, many Linux One actually works. It works quite well. It works right now. You should definitely be building them if you have a compiled module with no external library dependencies. If you do have external dependencies, you're going to want to think very carefully about the ramifications of bundling, though. And that's something I'm happy to talk about outside of this talk or in questions. So, good luck. Go forth and build wheels. And thank you very much.
Thanks very much, Paul. That was very interesting. Reminds me of compiling some Fortran 77 about 2 years ago with all of those error messages you had. Are there any questions from the audience? Should we take at the back there? Let's get a microphone.
As someone who enjoys playing around with my Raspberry Pis, it makes me sad that you say that PyPI just does not support the Raspberry Pi. Is that simply a case of needing to add more metadata to PyPI so it can support that platform? And would we need something like Many Linux or something, sort of a kid version of Many Linux to have a stable build environment so that we could make wheels for Raspberry Pi that would work on all the versions of Raspbian that have been out there?
PyPI has no overt restrictions. It's mostly just a function of metadata, absolutely. I'm not sure how many wheel tags have been applied for the ARM ABIs. The one trick, the ARM ISAs rather. The one trick with that, of course, is that there's a bunch of different versions of ARM. Now, obviously, we can handle just what Raspberry Pi does, but if we want to start handling ARM v8, ARM v7, ARM v5, that can start getting tricky quickly. That said, I believe there are people who are working on this. ARM is obviously a technology, an ISA that people find interesting, and especially with the Raspberry Pi, it's seriously unpleasant to compile big things, so it would be nice to have it be able to be done for you. I think probably the best, Nathaniel is probably the guy to ask, honestly. Yeah. And if not that, then Donald Stuft would know for sure.
I think Bruce had a question.
Hi, so I maintain a module that's written in C++ and obviously links against the C++ standard library. What are your recommendations for trying to make binary modules out of that, given the ABI nastiness with GCC? Every GCC version's got a different C++ ABI.
Yeah, the reality of that is effectively that on Linux, don't try. For now, don't try. There's really not a lot of way around that at the moment because of the C++ ABI issues. you might be able to get away, so when you generate a wheel on Linux, the initial wheel that gets generated has the platform tag. So it's not a many Linux 1 tag. So you can actually, if you know your target, like you know you're distributing to a specific version of Debian or a specific version of Fedora, then you can actually build the wheel and you can distribute that wheel independently. So like wheels work quite well for internal deployments where you control both ends. And there you can do the C++ stuff, no problem. But if you want to distribute it to other users, yeah, the unfortunate reality right now is don't use C++.
I think there's a question over here. Sorry, can I just quickly interrupt the Christo Goosen, because he's the next speaker. Okay. Next
Right.
question.
Do you know if there are any plans for mini Linux support of different alternate libcs?
Like muselibc or
Yeah.
something of that nature. At the moment, there are no plans for it. I would like to see that because obviously with the rise of Docker, things like Alpine and TinyCore are becoming more interesting. And right now, Alpine obviously can't use many Linux 1 because of the muselibc issue.
Yeah.
Muscle, rather, sorry. I always mispronounce that.
Yeah, I mean, we're basically doing just what you described to Bruce, where we're building things specifically for Alpine and then kind of distributing that internally.
Yeah, so I would recommend you should definitely actually file issues against the PyPA Mini Linux project. That lets people know that more and more people are interested in this sort of thing. To accomplish this requires one more PEP, but there are lots of people out there who know how to write PEPs. So you don't have to write the PEP. You just have to convince somebody that they want to write it.
Okay, thank you.
Any other questions? Well, I've got one question. If I wanted to do this and have a kind of start to finish kind of hello world example, does that exist? Are there some instructions that one can take and then build on that?
So for doing it across all the different platforms?
Let's pick the most popular platform. So
that's an interesting question because the most popular platform for binary wheels is probably the Mac, but actually the most popular platform will emphatically be Linux.
Sure.
So on Linux, there's a good example. Many Linux 1 has reasonably good examples, and then once the slides are posted, you can go to my repo, and that's an easy place to see an end-to-end, like, here's how you take your package, and here's how a wheel comes out the other side. Unfortunately, on the Mac and Windows side, the examples are more like, come look at my Jenkins config. You can definitely get to a manual process just by following what was said here. But to get it a full end-to-end, there's not a lot of great, like, just here, look at this one example.
All right. Any other questions? All right. Well, I'd like to thank Paul. That was a very interesting talk. And I'd like to wish him well for the rest of his stay in South Africa. I think he leaves on Tuesday. So hope you have a good time.
Thank you.
Yeah. And